Today we are going to continue with the series on units and dimensions. So we're going to look at the dimension of force, the dimension of work or energy, the dimension of power, and the dimension of what? Pressure. Let's kick off. Force. First of all, force. The unit of force is the newtons. The newtons. But now we cannot get the dimension of force from this newton here. We need to reduce this until we get to the fundamental units. We have to combine what the mass, the length, and what the time. Okay, so we need to get the equivalent unit to what? The newton. So now force. Force is mass times acceleration. Mass times acceleration. The unit of mass is kilogram. The unit of acceleration is meter per second square. That means the unit of force can as well be written as kilogram meter per second square. And this is an equivalent unit to the newton. So that means the newton is the same thing as the kilogram meter per second square. So now that we have the equivalent unit to the newton, which is the unit of force, from there we can get the dimension of force. Kilogram, we have M. Meter, we have L. Second, we have T to power minus 2. That becomes the dimension of force. Okay, let's proceed now. Let's look at work or energy. The unit of work or energy is the joules. The joules. But we cannot get the dimension of force from here. I need to get the equivalent unit to the joules. We need to get the equivalent unit to the joules. Most times in exam, they may not even ask you to get the dimension. They may just ask you to get the equivalent unit. You can see a simple question like, the newton is the same thing as dash. If you see something like that, what they are simply asking is the equivalent unit to the newton. And of course, today you already know that the newton is the same thing as what? The kilogram meter per second square. But that's the equivalent unit to the newton. So now let's look at the work or energy. Now work. Work is force times what? Distance. Force times distance. The unit of force is what? The newton. The unit of distance is what? The meter. Which means an equivalent unit to the joules is Newton meter. Newton meter. But still from here, we still cannot get the dimension of work. We still need to get an equivalent unit to this one. Now, based on what we did for force, we know that force is what? Kilogram meter per second square. That's an equivalent unit to what? The newton. So this newton here is same thing as kilogram meter per second square. So based on this newton, I will now write kilogram meter per second square. Then multiplied by this meter here. So that will now give us kilogram meter square per second square. So that means work or energy, the unit is either the joules or the Newton meter or the kilogram meter square per second square. So from here, we can get the dimension of work or energy. Kilogram speaks of M as mass. Meter speaks of length, L, to power what? 2. Second speaks of time, T to power minus what? 2. And that becomes the dimension of work or energy. The next one is power. Let's get the dimension of what? Power. First of all, you know that the unit of power is the watts. So now we need to get an equivalent unit to the watts. We need to get an equivalent unit to the watts. Power is the ratio of what? Work done over time taken. The ratio of work done over time work taken. The ratio of work done over time work taken. And then you know that the unit of work is what? Joules. The joules. So that means the unit of power is watts. The watts. An equivalent unit from here, work over time. Work is what? Joules. Work is the joules. Then time is what? Seconds. So we can write that as what? Joules per second. That is joule over the second. So joules per second, that becomes an equivalent unit to the watts. Joules per second. Joules per second. Okay. Now we need to get an equivalent unit to this again, because from here we still cannot get the dimension of power. Now we know that joules, the joules now is same thing as what? The Newton watt meter. Newton meter per second. That becomes an equivalent unit again to the watts. So we can have this as what? The Newton meter per second. You need to know all these equivalent units because of what I talked about earlier. They may not ask you to get the dimension, they may just ask you to get what? The equivalent unit to the watts. The equivalent unit to the watts is what? Joules per second, or the Newton meter per second. So now we proceed. The Newton, from what we did for work, the Newton is the same thing as what? Kilogram meter per second was squared. So we have kilogram meter per second squared. That's an equivalent unit to what? The Newton. Then we have this meter here, times meter, then this per second. So we combine everything here, I'll get kilogram, meter times meter is meter squared. Then second to power minus 2, second to power minus 1, second to power minus 3. So that the unit of power is also kilogram, meter squared, second to power minus 3. So now from here, I can now obtain the dimension of power. Kilogram speaks of mass as M. Meter speaks of length L to power 2. Second speaks of time T to power minus 3. This becomes the dimension of power. Next, let's get the dimension for pressure. Let's get the dimension of what? Pressure. Now pressure, unit of pressure can be the millimeter mercury. Unit of pressure is also Pascal. Now we need to get the equivalent unit to this or this. Now pressure is the ratio of force to area. Ratio of force to area. And force, the unit of force is Newton. Unit of area is meter squared. So that this one can be written as Newton per meter square. Newton per meter square. So that becomes an equivalent unit. So Newton per meter square. So we need to proceed again because we cannot get the unit of pressure from here. You know that in Newton is the same thing as what? Kilogram meter per second square. So I'll get kilogram meter per second square, then times meter to power minus what? 2. Kilogram meter per second square for the Newton from here, kilogram meter per second square, then times meter to power minus what? 2. So that this one will now give us kilogram meter to power 1 times meter to power minus 2. They give us meter to power minus 1. Now we have S, that's the second to power minus what? 2. So we have kilogram per meter per second square. So we have kilogram per meter per second square. Kilogram per meter per second square. Kilogram per meter per second square. So from there, we can get the dimension of pressure. Kilogram, mass, that's M. Meter, space of length, that's L. We have to power minus 1. Second, space of time, T, to power minus what? 2. And that gives the dimension of pressure. So now, you have understood how to obtain the dimension of force, work, power, and pressure. If you enjoy these lectures, ensure you subscribe to our YouTube channel. See you in our next class.